Okay, hey everyone. Today we're going to solve LeetCode 567 permutation in string. It's a medium level problem and the concept that it involves are very important. I think for this problem in solution section there are almost 7 or 6, I don't know, 7 or 8 solutions or approaches that is given to this for this particular problem. So I will not be going through everyone because if I start going through every approach then it will take you know like an hour or so I'm not going to do that. Their other approaches are relatively easier, but this approach is not like the difficult one, but this is very useful and it can be used in other programming questions as well. So let's see what the problem is. So we are given two strings s1 and s2 and we need to return true if s2 contains a permutation of s1 or false otherwise if it doesn't. In other words, return true if one of s1's permutation is in the substring of s2. So what this question says is, so for example, you have a string 1 that is AB and you have a string 2 that is E, I, D, B, A and triple O. Okay. As you can see, AB is this is a permutation, right? AB has a permutation that it can be BA and BA is present in the S2 as a substring that is BA. So we will be returning true for this case. But you can clearly see for this case we have AB, and in this case you in this S2 string you cannot find a substring which will give you a permutation of AB or BA. So that is why we will be returning false in this case. Now how to solve this question? So I'll be doing something called sliding window on strings, and it's a very standard concept used in a lot of programming questions, especially of sliding window and strings. So let's start. So we have two pointers, I pointer and a J pointer. Okay. So I pointer is responsible for inclusion or taking new elements into the window, whereas J pointer is responsible for discarding of element from the back of the window. Okay, so what we mean by this is, so for mind it, we will be keeping maps as well, because if we have map only then we will be creating a variable that is match count. Okay, and match count means how many characters in this window. For example, this is a window, right? And how many characters do they match with the frequency of s1. So in this window you have B and A, and this is B and A. So you have two characters that are matching. But if the window is reduced to this, now you only have B that is matching, so you will be saying that we only have match count as 1. But in order to have this match count variable, that how many characters are matching, we need to have map of both of these strings of or the window that we are looking for. So for this S1 map, I will say S map, and S map is A is 1 and B is 1 as well. Okay. Now we have an S2 map as well. So this is just an S map, S1 map, and we have an S2 map, but we haven't started our process. So S2 map is initially empty. Let me just keep these lines. Okay. Now you have S2 map, and let's start our process. So I is responsible for inclusion and J is responsible for discarding of the elements, but when to do so? So for example, I is taking new elements in it and the match count is now equal to 2, and match count length 2 means that it's equal to the size of the S1, which means that in this window we have all those characters that are in within S1, and now we can check if this window has a substring that is equal to the permutation of S1 or not, right? So this is the process. And when we need to discard elements, so for example we have created a window, but it also have elements. For example, in this window that I is pointing here now, and this is the window, okay? But there's a problem that we need ba. I accept that we need ba, I agree to this, but eid we don't need that, eid. So now I will be discarding them. So I will be saying that at jth position we have e. Do we need e? Is e present in S1? No, it is not. So I will be discarding it, and discarding it by saying that window is now reduced, j is incremented. Okay. And now we are currently focusing on I. Do we have I character in S1? We don't. So I will be saying that j should be incremented, and j is now pointing here, and now we are at this point, right? So this is the flow of the algorithm, and it will take linear time, or let's say s2 mod of s2 time. And yeah, so this is the problem. So let's see how to solve this, and the space complexity for this problem will be equal to the map that we are using, and it will be nothing but 26 characters, because a map will have 26 pairs of character and integer value, so it will be nothing but constant. So yeah, so this is the question. Let's see how to solve it. So first we need our pointers I, that is initialized with 0, j is initialized with 0, and we need a variable called match count. As discussed earlier, that match count value will be changing either how many characters that are matching in this window with the s1 string. So you have match count that is initialized with, you can initialize with 0 and it's fine, and then you have a, that's it. Now you need unordered map of character and int. So you have s1 map, then you need an s2 map, and now you also need flags, and I will tell you why we need flags. So flag 1 is equal to true, or rather than saying flag 1 I will say take is equal to true, and discard is equal to false, sorry, true as well. Okay, now we need to create our s1 map. So I will say I will iterate over all the characters in s1, and s1 map will have the frequency as, yeah, so it will store all the frequency of the characters. Now this is where the sliding window concept start. So we have flag 1, or let's say take is true, discard is also true. Now take is false, and discard is also set to false. And why we are doing this, I will let you know this, but before that we need to get grasp over some of the other concepts that are relatively more important and difficult to take. So now you will take elements. So when you take elements, you will say while I is smaller than s2 dot size. That is like a very basic condition, because you don't want I to be, out of the bounds issue. So you will say I has to be smaller than s2 dot size, and the match count, that how many characters are matching, is less than the s1 dot size. So if this is the case, which means that we have less characters that are matching with the string s1, we need to take more characters into our window and have a match count value that is equal to s1 dot size. Okay, so how do we take these values? I will say s2 map of this s2 string I increment. Okay, now we need to check if the character that we have taken is present in s2, is present in s1 string or not. And how to do that? You can run the string function as well, find function, or but there can be multiple characters, so that string find function will give you problem. So you need to check this frequency map. And how to do so? So you will say if s2 map of this s2 of ith character is less than or equal to s1 map of this s2 ith character. So if this is the case, then you will say match count is incremented. And now you are done. You need just be incrementing this pointer and you will say that take is true. We have taken few elements. Now we will work on the discard part, and the discard part is while so j minus I. So this is the length of the this is the length of the window. So if j minus I has to be, you know, greater than 0, because if it is 0 then we don't have anything to discard. So j minus I is, and it cannot be negative because j is always smaller than I, and it will give you a positive value. So if it will give you a length value that is 1 2 3, then we can discard characters. Otherwise, if it is 0 value, then we don't have anything to discard. Now I will say match count. If match count is equal to the all the that in this window we have those characters that we are looking for in the s2 as a substring, and all the characters that are in s1, which means s1 dot size. Okay, so if this is the case, now we need to find the length. So length is I, sorry, yeah, length is I minus j. So if this is equal to s1 dot size, which means the window that we have has all the characters in it. If a window has all the characters that we are looking for in s2 as a substring, then it means that this window is a substring, and we will be returning true in that case, that we have find our substring. Otherwise we will say that s2 map of, now we are discarding it. Okay, so s2 of j, now this value will be equal to max of, because we don't need negative value of the frequencies, so I will say s2 map of s2 of j, and this value is decrease the -1 or 0 value, that either decrease this value or 0 value, because if it is already 0 then it's -1 and we don't want -1 as our frequency, right? So yeah, now so if s2 map of s2 of jth character that we have discarded is yeah, so if it is less than s1 map of s2 of jth character, so if this is the case, that we have accidentally, well, not accidentally, that we have in our computational process, we have discarded an element which should be in our substring in our window. In that case, I will be saying match count is now decreased and j plus plus and discard is equal to true. Fine. Now, when this match count value is decreased, then you will know that we do not want to discard any further. Actually, we need to take few elements because we have kicked out some of elements which were useful to us. If the match count value will be decreased, then this match count will not be consistent now, and we are not going to discard anymore. We are going to end up in the take part, obviously by getting out of this while loop, and then the second iteration will be when we are taking few elements. And when we are taking few elements, we are increasing the match count, but at a point where match count is equal to s1 dot size, then we are getting out of this while loop, saying that we have all the elements that we are looking for. Now we need to decrease the size of the window. Then we will begin our discard part, and the cycle will continue itself unless we have find a string substring in s1 in s2 that is a permutation of s1, or if we do not find it, then we will be returning false, that we don't find it. This is it. Let's see if this will pass these test cases. Okay, it does. Let's see if this will be submitted. Yes, it is submitted, and well, it's good. It's doing good, I think. It's doing good. Okay, time part is not doing a lot good. Oh, sorry, space part. What is this? Okay, I think the solution that I have, theoretically, it's same. Yeah. So this is it. This is the problem. And if you have any doubts, you can comment below. If you want to find the source code for this problem, then I have given a gist link in the description. And if you want to try this problem yourself, then you can try this problem by the link given in the description. So thanks for watching, guys, and have a good day.